Hi everyone, my name is Ajay. I am from Marwadi University. I am studying in ICT department. Today I am going to talk about the topic is flow control. Outcomes. Upon the completion of the session, the learner will be able to outcome number 1 recall link layer services, and outcome number 2 we will understand flow control, and outcome number 3 know the flow control protocols. And let's recollect the link layer services. Yes, link layer service. Basically, the data link layer within the OSM model, highlighting its position between the network layer and the physical layer. See the down diagram. A simple network diagram illustrates the flow of data between devices with intermediate nodes involved. And the data link layer deals with frames and its second layer of the OSI reference model, and this layer responsible for moving data frames from one node to another node. Various services provided by data link layer, including framing, error control, flow control, physical addressing, and access control. Already we have seen framing and error control. In error control, we have seen about error detection techniques and flow control. The topic of, let's start with what is flow control. See in the next video. Suppose if we have a device A and we have another device B, two devices are going to communicate with each other. Let's suppose if device A is sending some data frames at very high speed, but device B is not able to handle that much speed. At one fine time point of time, device B will be losing all the data frames that was sent by devices, that is, so before sending the data, both the devices must mutual to only agree upon the flow control mechanism. So we can say flow control is a speed matching mechanism. Speed matching mechanism where the receiver should inform the sender at what speed the receiver can handle the data frames, and it becomes the responsibility of the sender to send at the speed at mutually agree upon. So what flow control does it? And the second point, flow control coordinates the amount of data that can be sent before receiving an acknowledgement. And the third point, in other words, flow control is a set of procedures that tell the sender how much data it can transmit before it must wait for an acknowledgement from the receiver. The meaning is, in networking, we consider both sender and receiver, but in flow control, we are mainly focusing on the receiver. Why? Because if there is a fast sender and there is a slow receiver, this will cause a problem because the receiver cannot handle the speed of data reception that was sent by the sender. In case if the sender is slower sender and receiver is a faster receiver, that's not at all an issue. So we are always focusing on the receiver. Fourth point, receiver has a limited speed at which it can process incoming data and a limited amount of memory in which to store incoming data. The meaning is whatever sender sends, the receiver will store everything in its memory and it will be processed by the receiver. If the receiver memory is filling up high speed, then the processing speed, then ultimately all the data will lost once. The memory is full, all the data will lost. And the last fifth point is receiver must inform the sender before the limits are reached and request that the transmitter to send favor frames or stop temporarily. Meaning is so that the sending process and reverse process are encountering no loss. This is the basic behind flow control. Let's now talk about the protocols involved in flow control accepts. Basically, protocol involves for flow control or categorized for noiseless channel and noisy channel. Noiseless channels are two types. There are simplest and stop and wait. And at the other side of the part of the noisy channel, there are three types: stop and wait ARQ, go back N ARQ, selective repeat ARQ. And the ARQ stands for automatic repeat request. Thank you guys.